Welcome to Study Loop.
So the lead ball is going in a vertical circle, something like this. And at some point in its revolution, it's released so that it goes vertically upwards, something kind of like this direction. And so we're told a few things about this situation. One is that the radius of this circular path is 1.5 meters, and also that the initial height of the ball when it's released is 0.75 meters above the ground. So that'll be this distance here. And we want to find out how high the ball ultimately goes. And we can do this by using conservation of energy. Um, we know that initially that this ball is going to have some amount of kinetic energy plus some gravitational potential energy. But in its final state, it's only going to have gravitational potential energy because at the top of its path, it's not going to have any speed. So we can also write this as just the initial kinetic energy is equal to change in the potential. And we could use the fact that the form of kinetic energy in terms of mass and velocity is 1/2 mv squared. And the change in the potential energy is going to be the mass times the acceleration due to gravity times whatever change in height this ball undergoes. We can also cancel out the mass because it shows up on both sides of the equation and divide by g. So we can get that delta H is equal to v squared over 2 times g. So if we want to solve for this change in height that the ball undergoes, we need to know what its initial velocity is when it's released from the circular path. So in order to do this, let's see what the problem gave us. So remember that it told us the radius of the circle is equal to 1.5 meters. It also told us that the ball it travels around the circle at a rate of 3 revolutions per second, which is the angular velocity. Revolutions per second isn't really the standard unit we use. We usually want to write it in terms of radians per second. Revolutions per second. So in order to convert this 3 revolutions per second into angular velocity in terms of radians per second, you can use the fact that for every revolution of a circle corresponds to 2 pi radians. So in that case, it's going to mean that the angular velocity is equal to 6 pi radians per second. And in order to find the velocity of the ball when it's released, we can use the fact that the tangential velocity of something in circular motion is given by the radius times the angular velocity. So in this case, that's going to be 1.5 meters times 6 pi radians per second, which is 9 pi radian, or sorry, that's, yeah, radians per second, which is approximately equal to 28.27 meters per second. That's our initial velocity. So remember that we were given from the last page, we know that delta H is equal to v squared divided by divided by 2g. And since that's a change in height relative to wherever it started moving, let's call the quantity y is equal to the final height, and its initial height was 0.75 meters. V squared over 2g. So with that in mind, let's go back to the text. Y minus 0.75 meters to v squared over 2g. We can plug in the values that were given. So the velocity here is what we just found, 28.27 meters per second. The acceleration due to gravity, 9.8 meters per second squared. And let's plug this into a calculator to see what we get. So the ultimate answer is y equals 41.53 meters. And just since we were given the initial radius and the initial height in terms of 2 sig figs, we can just round this to y equals 42 meters. And that is the final answer. That is the height that the ball reaches after it is released from this circular path.